Okay, this is section 5.4, looking at applications of exponential and log functions in real-life situations like business, finance, and science. So the first thing we're going to look at is simple interest, and we have some variables in our equations that we need to define first. So lowercase p stands for principal, and it's the initial amount of deposit if you have a savings account or an investment, or it's the base amount of a loan. So it can be applied in both situations. Lowercase r is the interest rate, and it's given as a percentage per year, and we're going to use that in decimal form, so we move the decimal place over to the left. The APR you might have seen in looking at a car loan or a house loan or something like that. APR stands for annual percentage rate, and that's just the rate of your loan. Lowercase t is time in years. Capital A is the accumulated value. So on a deposit, it's the accumulated value. For a loan, it's your total amount due. Capital I stands for simple interest, and it's the amount of interest computed only once during the lifetime of the investment or the loan. So this is why it's simple interest, because interest is computed once. So if the principal P is deposited or borrowed at interest rate R for a period of T years, the simple interest rate is given by the formula I is equal to PRT. Simple interest is equal to principal times rate times time. The total accumulated value, which is capital A, or for a loan, it's the amount due, is the principal, the initial amount you have deposited or borrowed, plus your interest. Here's that P is equal to RT, that's your interest. You'll notice that both of these terms have a P in them, so you can factor that out, which simplifies to the equation here at the right. This is the one we're going to apply in our example. So let's take a look at our example. Your sister wants to purchase an iPod that's on sale today, but she doesn't get paid for another 2 weeks. So she asks to borrow $150 from you and promises to pay you back $160 when she gets her next paycheck. Determine the annual percent rate of interest that you charge on the loan. So let's take a look at what we have. The interest that is being charged is 160 minus 150. So the interest is $10. The principal, or the initial amount of the loan, is $150. Time to pay back the loan is 2 weeks. But we need to put this in terms of a year. So 2 weeks is 2 out of 52 weeks in a year, which simplifies to 1 over 26. And our interest rate, that is what we're trying to find, our annual percent interest rate. So if we use the formula for simple interest, I is equal to PRT, we substitute in 10 is equal to 150 times R times 1 over 26, and we're just going to solve this by undoing. So we have 150 over 26, so if we multiply by the reciprocal, that's 26 over 150. Do that on both sides. And if we solve that, we end up with R is equal to 1.73 repeating. And remember that this is in decimal form, so if we want to turn it into a percentage, this time we have to move our decimal twice to the right. So this is saying the interest rate on this loan is 173.3%. That's pretty steep. We could also solve this equation with the formula for the total accumulated amount. So A is equal to P times 1 plus RT. So let's just solve it with this equation. You'll see how this works. And the total amount due for the loan is 160. The principal was 150. times 1 plus r times 1 over 26. And again, we're just going to solve this, so divide both sides by 150. We get 1.06 repeating is equal to 1 plus r over 26. Subtract 1 from both sides, and then multiply both sides by 26, and we end up with the same answer. R is equal to 1.73 as a decimal, so 173.3%.